Hi students, thanks for joining me. It's Mr. Nguyen. Today I am going to show you a few examples of applications of exponential growth and decay functions. So let's jump right into it. For example one, we have Kiara who has $50 in her savings account and it earns her 5% interest compounded annually. What this means is the bank does her interest or calculates her interest once a year, right? So annually means once a year. To the nearest cent, estimate or find out how much she will have in 2 years. Well, how do I know if this problem represents a growth or a decay? So what you do is you look for keywords, right? In this problem, it says her savings account earns her money. So earning means it represents a growth, right? Your account earns more money, so it get bigger. So now that I've determined it's a growth, I use the growth formula, right? The growth formula is f of t, the function of time or over time, is a times 1 plus r raised to the t power. Where a is your beginning amount, the initial amount that you put down or you start with. Uh, R would be your rate of increase in this case, right? Because you're gaining more money, so you're growing, the growth rate. And T would be the times in years that you that Kiara invests her money. So now that we know the formula, I call this formula S of T to represent savings, right? The savings as a function of time. So S of T, you could call it whatever you like, but just know that the function is the output, and the output would be the final amount of money that she will have in 2 years. So now we find out all of the variables that are in here. So her A would be the $50 that she has opening the account, right? She has in her savings account. The rate would be the 5% interest rate. Now notice 5% means 5 divided by 100, which actually is 0.05 as a decimal. And that's the decimal that you'll be using in your formula. And T would be 2 years. We want to find out how much money she has in 2 years. We could do this for 5 years, 10 years, 15 years, 25 years, whichever you like. You just change the time, right? And then we substitute it all into our formula. Okay, 50 times 1 plus 0.05 raised to the second power. And we carefully type all of that into our calculator. All right, and we hit enter and it tells us 55.125. If we round this to the nearest cent, that means Kiara will have in her savings account $55.13. You will want to round that up, right? So $55.13. That doesn't seem like a lot of money over 2 years, right? Well, it makes sense kind of because she only put in $50 and the amount didn't even change, and she only earned 5% interest a year, and the bank only calculates it once a year. So she only earned about $5.13 in interest plus the $50 that she has. So she only has now $55.13. So the moral of this problem is if you want to earn more money, put down more money at the beginning. Anyway, next problem. Example two. We're talking about number of subscriptions in a magazine. Okay, in 1996, they had 16,450 subscribers. And then since then, the number of subscriptions actually increased by 9.2% each year. And then the company wants to approximate the number of subscriptions in 2018. Actually, we're going to approximate that number. But let's say you work for the company and you want to approximate that number. So how do we do this? Well, first we have to determine whether it's growth or decay. Well, the word increased here indicates it's a growth. So we're going to be using the growth formula, okay, which is the same formula we used on the last example. So now we have to find all the A, the R, and the T. Well, the A is the number of subscriptions that you begin with, right? So in this problem, I use S of T again, but S here is not for savings. S here is for a subscription. Aha. Anyway, A would be the 16,400 and 450 subscribers that they started out with in 1996, or that's the year they want to begin the estimation. And then the R is the 9.2%. Again, every time you have a percent, you have to divide by 100. And then the actual number is 0.0292. And that's the number you're going to be using in your formula. Okay. And then T, well, to find out the number of years, we'll have to look at the number of years that the year that we want the estimation and the year that we begin the estimation. So we want the estimation in 2018, and then we begin the year 1996. So we subtract these two numbers, we will get 22 years. So the number of years that we're going to be using in our estimation would be 22. Okay, so we substitute everything into a formula like before: 16,450 times 1.092 raised to the 22nd power. Okay, and then we will carefully type that into our calculator. Okay, don't leave any zero out and don't add any extra zero. And the calculator says 114,041.7693. Okay, so subscriptions, it's a whole number. You can't have 0.76. So if you want to make the number look a little bit better, you're going to round all of that up. So I would say the subscriptions in 22 years would be 114,042. Okay. Now, some company would just drop everything and say, oh, it's about 114,000 subscriptions, right? And they just drop the 42. But for the sake of our math, we're going to leave it as 42. So in 22 years, their subscription numbers would be pretty large, I say, right? But 22 years is a long time. Anyway, enough blah blah. Example 3. In 2012, William bought a fancy new boat for $28,500. If the value of the boat depreciates by 8% each year, find the value of the boat in 2018. And again, we're estimating how much this boat is going to be worth in 2018. Now, just so that you know, a boat is a luxury item, and luxury items usually depreciate. And if you don't know what the word depreciate means, it means you're losing value. Okay, so this is a decay problem. Okay, luxury items will lose value, except for gold, and I guess your house. Your house is not a luxury, but your house don't lose values. Anyway, this is the decay problem. I will use the decay formula. Now, notice the only difference between a decay and a growth formula is the plus and the minus sign, right? The minus sign is because you're losing value. So you start with 1 and then you start losing. Versus the growth problem, you start with 1 and then you're gaining. So you're adding, right? So the subtraction and the minus and the plus is the only difference. All the letters are pretty much the same, right? So now we have to find out what each of these letters are, right? So I call this D of T for my function, for my output. So D for depreciate or decay, okay? So the depreciation value over time. That's what the function is. So it's the output. My A is 28,500 because that's the beginning value of the boat. My R is the rate that is losing value. So it's 8%. Again, we divide by 100, we get 0.08. T is our time. Again, to find out the time, you take the year that you wanted to estimate, and then you subtract the year that you began the estimation. So in this case, we are in 6 years, right? We're doing this in 6 years. So we substitute everything in, just like before, except for the minus because we're losing value. And then we carefully type all of that into our calculator. No more extra zero, no less zero, right? Make sure you type in things correctly. And it says 17281.11754. Okay. Well, we're talking about money, so we're going to round this to the nearest cent. So William's boat will be worth at $17,281.12. Okay. Yeah, that's almost half of the value in 6 years. So unless you're really rich, anyway, I can do a lot with that money. So no boat for me. Anyway, Last example. In this problem, we're talking about a population of animals. So we start with 200,000 in 1980, and then this number has since then decreased, and they came up with a rate for the decrease 4.5% each year. And then we want to estimate how many animals will be left by the year or in the year 2025. Okay, so what is this? A growth or a decay? Well, some keywords tells you decreased is a decay problem. We're going to use the decay formula. Substitute everything in. I call this P of T. P for, you guessed it, population. Population over time, right? Population is a function of time. That's what it means. A is 200,000. That's the number of animals we start with in 1980. The rate that these animals, I guess, dying or they disappear on Earth, from Earth, 4.5%. Divide that by 100, you get 0.045. The number of years, again, we take 2025, the year that we want to estimate, and then we subtract the year that we begin the estimation, which is 1980, and we get 45 years. Okay, so we want to estimate over 45 years. Substitute everything in. Now be careful. There are only 5 zeros. 200,000. Don't put any extra zero into your formula. Okay, so 200,000 times 1 minus 0.045 raised to the 45th power. Yes, that's a large number. Anyway, type it all into your calculator. And it says 25,187,000 point blah blah blah. So the population of these poor animals would remain at 25,187. So why do we do these kind of things? Well, we use these formula to estimate so that we have an idea, we predict, so we have an idea of where we be standing, and then what can we do in the meantime. So in the span of 45 years, what can we do to either slow down the decrease, change the rate, or make sure that these animals do not disappear that fast. Okay, what can we do? So intervention is part of why we do these predictions, and these are some of the examples of exponential growth and decay. Okay, so let's the last thing I want to talk to you about is the tips on how to solve these problems, right? So what do? Well, three easy things, three easy steps. First, of course, you read the problem carefully, right? And you have to determine, does this problem sound like it's decay or it's a growth? And to help you figure out which one, you look for some keywords, right? So some words that describe growth would be increase, growth, appreciate, gain, earn, etc. Okay, there's so many words, but these are some of the most commonly used words, right? Words to describe decay would be decrease, reduce, depreciate, losses or loses, deplete. Okay, that's a big word, deplete, etc. But some of these are commonly used words again, right? So you read carefully, determine which one it is, and then of course, once you determine it, you will use the correct formula. If it's growth, use the growth formula. If it's decay, use the decay formula. Then you'll find all the values for your A, R, and T, which are given in the problem, right? So the function, just keep in mind that's the output, that's the final amount that you're trying to find. A is the starting amount given in the problem. R is the rate. If it's growth, they give you growth rate. If it's decay, it's a decay rate. So it's just the rate, right? Just make sure you divide it by 100 because it's usually given to you in percent form. To change it to decimal, right? So it's given in the problem. T is also given in the problem, right? Find out the number of years that it takes. to increase or decrease. This is your input, right? And this input can change. Um, and then, final step, enter everything into your calculator carefully to get your answer. Okay. I hope this has been a pleasant experience for you. And I hope you can join me next time for some more videos on math problems. Okay. Thank you for joining me.